to SDN Tech Forum. This is SD Access Bootcamp Part 4. Now we are ready to onboard our device or discover our devices into DNS Center. We have done all the basic housekeeping configuration on DNAC, and now let's prepare our device or stage our device to get it onboarded on DNS Center. So we are looking into device discovery and inventory. Discovering the device is like DNS Center go ahead and process finding network device information, and that's what is the discovery. Once the device is discovered, it is reflected into DNAC inventory. A word about IPDT, IP device tracking. This is the way DNAC tracks the connected host and comes very handy in terms of wired mobility, as well as it is prerequisite for TrustSec. And we will also touch base upon telemetry. So NetFlow and TDL subscription based telemetry, we will touch base upon that. Mind it, IPDT configuration doesn't get enabled on border router. It is only enabled on access routers. Now, Dnac Inventory. Dnac displays the device information gathered during the discovery process in the device inventory view, and I'll show you. And DNS Center periodically polls the devices within inventory to collect the device related information. Okay, and there is a device role concept which we will talk about a little bit in the video. All right, so this is our first device, CAT 9300, and this is going to be a role of outside fabric or a shared service device where we have all our DNAC, ICE, WLC and other things connected. So this is not going to be part of fabric. And why we have started with this? Because we want to show you, or I want to show you, what is the configuration that will be applied when you discover this device into DNS Center and when you assign it to the site. All right. So this is, I'm doing some config diff right now, not very important. What we will do, we will just erase the configuration, do a complete write erase, and discover this device again, all over again. So right now you can see this is from the previous discovery, from my base configuration to what it has today. And this is the Dnac view. We have the CLI, SNMP, V2, everything is ready. Now let's go to DNSC, and right now you can see there is a zero device, no device on my DNS Center. This is going to be the first device. Remove all config, then apply base config. That is our goal. So to remove config, you can simply do write erase, but write erase will only delete the NVRAM or the startup config. It's not going to really delete VLAN file. So we will do a thorough deletions. We want to make sure that we delete the startup config, we delete all the existing keys, and we delete the VLAN. So for that, this is event manager applet, and we will run this applet, and it's going to destroy my all the config and reload the device. All right. So right now, this is sitting in my flash, and I'm going to copy it from flash to running config. Once it is part of running config, you can go ahead and initiate or run this event manager applet. So I'm doing I'm doing copy from flash to running config, and as you can see, it's been copied. Now you can run the applet. And the applet job is simple. It is going to delete a bunch of configurations, VLAN file, SSH keys and all, and reload the device. Because that's what we want. We want this device to come up without any prerequisite configuration, like a clean slate configuration, so that we can apply base config and run our discovery job from DNS Center, so that this device is discovered, and we will see during discovery what are the commands which Dnac is applying on this box. All right, device is being reloaded. It is coming up with 1711. auto install, trying to do auto install and PNP. We do not want to do any PNP, so just press couple of enters and say I don't want to go into initial configuration dialog mode. We will apply the base configuration manually. Okay, as soon as you delete the key and reload device, a key named TP self signed that will be generated automatically, so that is good. Now, as you can see, there is no startup configuration. That's why switch came up as like a without any host name, and this is like a default configuration, no manual configuration. This is what happened many a time when you receive a switch and you try to console, you connect a console cable and connect to it, you will see these are some default configurations. What I'm trying to do, I'm trying to make sure that there is no existing or old certificate on my device which point to the DNAC, because this device was part of DNAC earlier. So I'm scrolling through the config, make sure it looks clean, no stale or old information in this, and we will go ahead and apply the base config. On Cat9K switches, you will see that VRF management is a default VRF. It comes and it is applied to gigabit Ethernet 0 bar 0, which is used as like a management interface. Now we are ready to apply base config. You can have in base config we are doing very minimal stuff, and you will see what is my base config looks like. It is sitting in flash. So if you do more flash in the config name, this is the configuration we are going to apply. Host name, enable secret, we will enable IP routing, and couple of, since this is a shared service, I know a lot of devices or services are connecting to that. So this is my base config, trunk port interface, running ISIS and all those things. But when we onboard border or fabric edge, the base config is not that intrusive, you will see. So basically right now what is here is this is the shared switch, and we have DNAC connecting. In my lab we have DNAC connecting directly to the shared switch. We have similar information for ICE and other things. So that's the basic configuration I'm applying, but it has nothing to do with the fabric yet. Once I apply the base configuration, I have applied a IP address on gigabit 0 bar 0, which is in the same subnet of DNAC. It doesn't have to be, but somehow you have to make sure that DNAC has a reachability back to the switch so that it can SSH to the box and it can discover it. So now I have applied base configuration. My switch is in install mode, and we will discuss bundle mode and install mode going forward when we do a dedicated software image management video or a LAN automation video. All right, now what I'm trying to do, I'm trying to SSH to the switch from DNA center, and see we are running into an error, and it says that no key exchange common algorithm is there, and that's the error message I see on my switch side also. So when DNAC is trying to SSH to the box, it is saying that there is no matching key exchange algorithm available between server SSH server and SSH client. And we will see where is the problem. So IP SSH, and you can see KEX algorithm. I have only one algorithm available, which is Diffie-Hellman group 14 SHA-1. This is the old algorithm. DNAC somehow doesn't support that. It wants some advanced algorithm. So that means it is a issue at my switch side, right? And this actually is totally related to this software release. So you may not run into this issue, but I still decided to show it to you because we do not want to mask any problem, right? So here, even before discovery, we are running into an issue. The key exchange protocol is not matching between DNAC and switch, and DNAC cannot SSH to that. So what we can do, after some investigation, I realized that this is a bug and we have to upgrade our switch, and that's what I'm going to do. IP SSH server algorithm checks. You see, I have only one option available, Diffie-Hellman group 14. So it's not like something I can tackle with additional line of configuration. No, uh, some investigation showed that this is a bug, and probably I have to go to the next release, maybe 17.3 or 17.6. Okay, so now, so the communication between DNAC and the switch is broken. I cannot leverage or use DNA Center to upgrade this switch. I have to do it manually, and that's what I'm doing right now. Copy SCP flash VRF. This is a VRF aware copy. So what I'm saying, that copy from SCP location to the flash location of this device, use VRF management. So that's the network you have to use. Apply the source username, file name, and it will copy from your SCP location, whatever is the SCP location. And this is my SCP location. It's basically a Linux VM where I have my new image stored. So what I'm trying to do, I'm trying to copy or fetch that image which is on the Linux VM back to this switch. It's simple SCP. All right, so once it make SCP connection, you have to put your password, the VM password, and you see the file transfer started. So it is actually increasing the length of our video because we run into a problem. We realize that how to fix that, and now we are trying to fix that by upgrading the switch. So the transfer is complete. You can check dir flash include the newer release. The release is available. Its size looks good. You can do a MD5 or SHA verification also. Uh, I advise you to do that. Now, what we'll do, we'll do one shot install by using install add activate utility. So this is a single line command which you can use to upgrade your box. It starts with install add file boot flash, the image name, and then you can say activate, and also you can do commit. Even better, you can do no prompt. That means it will not ask you any yes or no. It will simply proceed with the upgrade. Let's verify the version and mode. The mode is important because install add may not work between bundle and install. So always make sure that what is your mode and what is your initial. I'm doing some additional checks like show install inactive. If there is any inactive packages, you can clean them up. Right now I don't have anything. What is my active image? That's 17.1. And what is my committed image, which should be again 17.1. So your active and committed should be same. Otherwise, if you reload, it will always come up with the committed image. So make sure the image what you want or intended to run, always it is in committed state. So for us, this new image 17.3 is good. We are going to say activate and commit and prompt level none, because I do not want to sit in front of this and keep on saying yes or no. So it is safe to say none. Configuration is modified. Do you want to save? Say no. This sometimes tricks user, but yes, it's safe to say no. Now it will just go ahead, activate the package. First, it will install that bin file, untar it, then it will try to activate. Once it is activated, then it will commit. And obviously, this is not a hot patch. This is a software upgrade. So my device need to be reloaded. This is a single switch. It's not a stack of switch. Based on what you are running, what hardware configuration you are running, stack or single, the upgrade time may differ. So be patient. but you can watch all the logs from the console. So yes, we have deviated from our initial topic, which was DNAC device discovery, but these things comes handy if you know, if you run into any you what are the things you need to check for discovery, like if Dnac can reach to the device you are intended to discover, or the CLI what you have defined is properly configured, and DNAC can SSH to the device. All those things you should know how to verify, and then you are ready to perform your discovery. And if you run into any issues, you know how to troubleshoot it. All right. So we are going from 17.1 to 17.3. It may be required a EEPROM upgrade also. That is a firmware upgrade before the software upgrade, and it can increase length of time. I paused the video to save some time. Now you see the switch is back up. Let's try to log in and see what is the version I'm running. I'm running new version 17.3. It's in install mode. So we started with install. We did a one-shot install for upgrade, and we ended up in install mode. Let's see what is my active package, what is my inactive package, and what is my committed package. So active package is 17.3, committed package is also 17.3. So it looks good. Now coming back to the original problem, show IP SSH key and see what is the option available for us for KEX algorithm. Now you can see I have many more options available other than Diffie-Hellman group 14. And now let's see what is the behavior at DNS center. And I am trying to SSH in verbose mode by doing -v, and you can see all the SSH exchange. The key is negotiated properly because now you have more options. The switch has more options to offer to DNAC, and they negotiated between one. Feel free to pause the video and take a look at the verbose output. And now DNAC center has logged in to the switch. So we mitigated our initial problem. All right, let's go back to the original agenda now. Tools, DNS center, tools, discovery. And right now I haven't run any discovery. That's why this is the default page. Discovery type number is 0. Let's go ahead and create a new discovery. So for new discovery, you have to say discovery name, and then you can discover based on the CDP, LLDP, or you can define an IP address range. Within IP address range, you can say from and to. You can pick a large subnet and discover multiple devices at the same time. In my case, I'm going to just try to discover only one device. That's why my from and to, they are the same IP addresses. These are the credentials I'm going to use. CLI credentials, I named it as a fabric devices. My SNMP v2, SNMP read and write, all those credentials are there because we defined that in planning part of the video, right? So if you haven't, you want to refresh your memory, go back to part 2, where we are dealing with the network design. Now I'm going to put one simple event management CLI so that whatever command Dnac is pushing, we can see that in switch console. Looks good for discovery. If you want to add or edit your credentials, this is where you can come. You can go to DNAC, network design, device credentials, and edit your credentials. You can manage your credentials. Telemetry, we will look at the telemetry setting right now. So we are enabling SNMP traps, we are using syslog, and we also enable netflow. Wired endpoint data collection is a TDL, and we will deal with this when we come to telemetry. And wireless access control telemetry as well. So let's leave these things default. Once our device is discovered, we will apply telemetry. So let's go back to our discovery workflow. Device controllability is enabled. That means when that indicate if Dnac is managed to discover this device, it is going to apply some commands. And if you want to learn more, you can click here, or you can see that what happened during device controllability or as a part of device controllability. Pause your screen, give it a read. You can see that the device controllability will push SNMP credentials, network credentials, and if you have your telemetry configured, it will push those subscription information. So please pause this, give this a read, and make yourself informed about device controllability, because after discovery you are going to see new lines of command on your switch which you didn't configure by hand, but it happened as a part of DNAC provisioning or discovery. Discovery and provisioning, they are two different things, but I'm using them interchangeably for now. uh, Basically what I'm trying to say, that commands which DNAC pushes to the network device based on our workflow. All right, you can schedule discovery for later, but we want to discover now. So let's run this, and as you can see, my discovery started. You can always go back to task, activities, task, and see what task you're running. I discovery name was not very self-explanatory, so try to name something which can explain what kind of task you are running. In my case, I didn't do it very good, but as you can see, the top task which says fusion status is in progress. That means device discovery is in progress. And if you want to check, you can obviously go to the right hand side and click on refresh. All right, let's go back to the switch console and see what is happening. As you can see, because I have put that extra line of command, I can see every commands which is being sent to this device. I can see them here. So you see a lot of show commands, and these are the commands DNAC is executing. So you will see that DNAC source Dnac logged in as a local port 2020 22. That means Dnac is already SSH to this box and trying to run some show command and some configuration commands. Let's go back, hit refresh. DNAC is success, and device discovery is success. You can try to expand that task, view discovery, and it will take you back to the discovery page, and you will see more details about the discovery and the result. As you can see, one device discovery is success, and that's what we were intended to. My status is all check. ICMP is good, SNMP is good, CLI is good. You have to make sure that your netconf also looks good. No spoilers, but we will talk about why netflow is not looking good right now. Yeah. Now, so device is discovered. Let's see what is the config diff between my base config and running config, so that we can ensure that yes, during device discovery, as a part of device controllability, DNAC has issued some config level command, and that's what we can check using config archive differences. So we are comparing configuration as my base config, which is saved in flash, and running config. Okay, and whatever you see plus sign, they are the additional configuration, or they are the diff between base config and the running config. And as you can see, I have some some keys. I have some additional key maps, IPDT config, some class maps, some IPDT config. So these are the things came from device discovery process. As you can see, this is like a not too much or not too radical kind of config. Let's look at the show run one more time. SLA trust point, TP self sign was there already there. Also, start paying attention to the licenses, and we will talk about licenses in the later part of the SDA bootcamp. But make sure that you have DNA Advantage license if you are intent to build a SDA solution, because a lot of things are now getting tied up to the licenses. Okay, these are my base config. My interfaces looks clean. I have a couple of VLANs created, which is like a future config. When we start pairing with the border, during that time, you'll see that those VLANs and those BGP configuration comes handy. All right, now my inventory view, since DNAC discovered this, it is now assigned into inventory. If you go to inventory, it has already made it part of inventory and identified the right kind of hardware. So it's now it has classified as switch. As you can see, EOX status and scan and compliance, a lot of things are out of sync now. Let's see why my startup config and running config is looking different. As you can see, some call home configuration was there in startup. They're not here, or this just shifted basically. So that's not really a difference. And obviously, as you can see, the event CLI applet, this one we configured manually, and I didn't do a write a mem myself. So that is why that is showing up as a different between startup to the running config, and which is uh, actually expected. So Dnac didn't push that configuration. Now let's take a look at telemetry part of it. So now the device is discovered. You can go and collect inventory, devices, edit device, action, edit device. Here you can see various configurations, and you can, if you want to change at the individual level, that means particular to that device, you can make those changes here. Like I enabled netconf port 830 on this. And if you want to find more about netconf, there is a video link in description. Please go ahead and watch, and that will be very useful. All right. Dnac sometimes can be very chatty. Every time you make any changes, Dnac actually logs into the device and try to gather the same set of data. So it's better if you want to watch something, be on console. Otherwise, you can just initiate a SSH session so that you don't run into this excessive commands here. Let's see. Show run include netconf. Though I enable the netconf setting on DNS Center, but on switch, I do not have anything configured for netconf. That means I didn't enable netconf facility or feature on the switch itself. I should have done that as a part of my base configuration, but intentionally I missed that so that I can have a section talking about netconf, and to enable netconf on a cat9k, you have to do bare minimum. You just have to configure one single line. If you want to restrict netconf session, that who can connect to this device using netconf uh, protocol, then you can apply a ACL and apply it to the SSH session. But we are not going to, we'll keep it open, but it's always best to secure your device hard as a part of device hardening. Make sure the netconf services is open to only for legitimate users, that is DNS center in this case. Okay, let's go to telemetry. I want to use DNS center as NetFlow collector. That means all my devices, they should send their NetFlow back to DNS center, so that DNS center can parse them and give us some application visibility and other telemetry information. If you want, if you are a CTV customer, Cisco Telemetry customer, then you can configure CTV as a destination for all your NetFlow. But make sure on CTV you have a destination created which is pointing to this DNS center, so that DNS center is actually receiving NetFlow information from CTB, not directly from the switch. But in our case, we will not use CTB. We'll make sure that DNS center is receiving the NetFlow information directly, and we are going ahead and enable wired endpoint telemetry, which will create some subscriptions. Again, I'm talking about subscription in the link in which is available in description, and enable wireless telemetry also. So if you want to know about subscriptions, netconf, yang, please watch that video. All right, so changes are saved. So now we are ready to enable telemetry on the device, which we just discovered. And mind it, DNA, after discovery, the device is available in inventory, but it is not assigned to any site yet. Okay. As we enable that, it is not provision, of course, because we didn't provision, and it may, based on what is the golden image you tagged, it may also prompt you to update the image. So DNA settings looks good. We are ready to enable the telemetry, and the manageability go into transient state sometime. So now, right now, it is complaining that you do not have netconf enable on the switch, though you have enabled netconf for this device from DNS center, but netconf is not enabled on the switch. That means DNAC is not able to SSH to the switch using port 830, and that's why you can see the netconf box is not having a check mark. So you can enable netconf on the switch and do a rediscovery, like I'm trying to do a clone. Netconf doesn't need any credentials, it's right over SSH, so it can use the same SSH set of credentials. All right, so if you want to rediscover, you can just clone that and change the parameter, whatever parameter you want to change, and you can run your discovery again. We are touching base on a lot of concept, and I know it is increasing the length of the video, but be patient. It will help you get a strong foundational knowledge around the interaction between DNS center and this inventory. Again, because of our event applet, it is capturing all the commands, and every time you make any changes, DNAC go ahead and run the same set of commands. So that's why you see the console getting busier. All right, here device is discovered, and this time I have netconf port enabled on the device within Dnac inventory, but still I didn't get a netconf checkmark. Let's go and see. It is in managed state, but Dnac is managing the device purely on SSH, solely on SSH. Show netconf session. So now we are trying to troubleshoot netconf, and these are the few show command you can run. If there is any active session going on, you can see the sessions here. So the single line of command what you need for netconf is netconf -yang. As soon as you say this, switch will start the netconf process is on port 830. So it will start listening on port 830. My telemetry settings are grayed out because until or unless you have the netconf connectivity between the end center and the switch, you cannot apply telemetry. And I'll show you what goes in as a part of telemetry configuration, and we will see the entire command line. So now let's go ahead and assign this switch to a site. In our previous video, network hierarchy video, we created a couple of sites, east, west. Within east, we have east 01 and 02. So let's go ahead and create assign this device to a site which is east 01 in this case. And you can see the following settings will be deployed during assignment of the site. And it's all listed here. SNMP trap, netflow, syslog, basically whatever you planned uh, or spend time during planning. Now those parameters will be configured to this device when this device becomes a part of that site. Before running that workflow, you can also do a generate configuration. So it will show you a preview of the configuration it is going to push. You can look at it, and once you feel comfortable, you can deploy it. So right now the task which is running or work item which is running is configuring preview generation. It's very nice. It's actually uh, good to see the actual configuration. If you are a CLI kind of person, it's always good to look at what happens when you express an intent. Like, I want to assign it to site, that is an intent. When I express that intent, what happened under the hood? And looking at the CLI, you better understand it. So this is the complete configuration which DNA Center is going to push as a part of site assignment. You see, based on role, because the default role is access, this device is going to get IPDT configuration, it is going to get netflow, syslog, and other configuration. Once you feel comfortable, you can say apply, and now the actual assignment task kick in. So earlier it was a workflow, now it is actual task running, and you can see from console DNAC is going to log into the device and start configuring or pushing those command line directly to the device. And here you can see trust point DNAC CA created, and this trust point will be used to create a secure channel between DNAC and this switch. So every switch which present this certificate to DNAC realized that yes, this is the trusted switch, it is part of my inventory. So this is this certificate helps establish a trust relationship between DNAC and actual inventory, and that's why it is important. After configuring, it will again run some write. As you can see, any intent you express and Dnac take it as a task. After completing that intent within the command line, it actually go ahead and do a write mem. So that means if device get reloaded, the configuration is not lost. So Dnac intelligently does a saving of configuration by using write memory. Once it is configuration done, it does a clean connect out or log out from the device, so that your number of sessions or SSH sessions is not exhausted. Now let's do another set of diff. I forgot to save the configuration after discovery. So let's compare the configuration, running configuration, which is after assignment, all the way back to the base configuration. So whatever the difference you are seeing, they are coming out of two two intent. One was the discovery, or second is assign. So basically we perform two tasks after our initial configuration, and this is what you see. Now I do have IPDT policy, which is very important for telemetry and wired mobility, and we have NetFlow, we have syslog, we have bunch of SNMP traps, very important. This comes all after all from DNAC directly. Mind it, my VTI line 0 to 4 didn't get any ACL or any named method. It's still very open, and we'll see when we do our radius configuration, we'll see how that changes. But site assignment and device discovery doesn't restrict your VTY access. Now let's go back to inventory and see if anything changes. Our reachability is still reachable. Type is supported. You can see all the details about switch. You can add, delete some of these parameters if you don't want to keep it here. Go to action, telemetry. Now you see I have the telemetry knob available, right? And make sure that you have DNA Advantage license available for application telemetry. I do have that license. That's why it says enable application telemetry initiated successfully. As you can see, NetFlow configuration is getting pushed and it is getting applied to all the interfaces. So we are seeing that we have two flow monitor for IPv4, one for IPv6, one for IPv4, one for IPv6, two flow monitor getting applied in input and output direction of all my interfaces on the switch. And that is coming as a part of telemetry, application telemetry. Again, we are comparing base to running, and now we have performed three tasks. And as you can see, these are the new commands being available. Flow exporter, basically the new thing coming out of application telemetry is the NetFlow part. So spend some time while you are configuring or assigning a device to a site. Make sure you understand what kind of configuration is coming to the box and what is the purpose. If you know that, you won't be confused because the device configuration can grow up pretty quickly. So if you can remember on high level what happened in each stages of this workflow, like discovery, assignment, updating telemetry or building this device as a part of fabric, that will help you or make this technology less complicated for you, or make it less overwhelming for you. Otherwise, device configuration, the number of command on device can grow up pretty quickly, quite significantly. Okay, so we have performed three tasks other than troubleshooting, which we ran before discovery. After that, we have performed three tasks: discovery, site assignment, and telemetry update. Now, you may see this that some devices are not configured or discovered with netconf. So you may have to apply a force configuration push for telemetry. So let's try that because I'm getting that. And you have seen that I didn't discover my device with netconf because the netconf.yang was missing during device discovery. So let's go ahead and try to do a force configuration push for telemetry setting. Again, select the device. This is the nice way to find more information of the device. This is the cool thing that you can run command runner directly from the inventory page, or you can cross launch to view 360, which is all about this device, which become part of like assurance. So this is a device 360 view of the newly discovered device. So you can come here and you can see everything about device, how your device is doing, what is the IP address, model, role, software version, any issues associated with that, and what is the topology looks like, application experience. Since you have enabled NetFlow, you should immediately see some application experience, um, and you can run some troubleshooting like path trace, etc. Any issues reported as a part of syslog, or any event generated, you will see all those information here. Again, switch detail, which what is the reachability status, what is the uptime, all those information is here. And we will talk about assurance in detail after finishing our SDA build towards the end. Okay, and as you can see, I'm just going through the network setting SP profile. We'll talk about that, wireless and other things later in later video when we do wireless. And look at the telemetry. These are the standard telemetry settings which we already enable. Excuse me. Inventory, edit device, netconf, port 830. Let's enable port 830. We did that earlier, but for some reason it didn't take effect. So let's go ahead and enable port 830. That means this is for netconf. This port number will be used for netconf. And now let's try to update force telemetry configuration. Telemetry configuration, and here you have to check this box, force configuration, and let's do a couple of clicks so that we know when the force is being applied. And before that, let's validate if we can do a if Dnac can actually do a netconf configuration. All right, so this is SSS session to the box. So discover config to system current config. Here you go. After that telemetry push, the forced telemetry push, you see this IETF subscription, the new subscription. This is the TDL telemetry that started showing, and the certificate what you have seen before uh, just a minute ago, that is SDN infra. That is the certificate used for telemetry communication between DNA center and the switch. So now we have mitigated the netconf portion. If you have enabled netconf during discovery, the switch will inherit this TDL configuration when you enable telemetry at the first time. But for us, we have to force it because we didn't discover our devices enabling netconf. All right. So make sure that you see subscriptions and you see SDN-infra certificate, because that is the certificate will be used for telemetry data exchange. There are a couple of certificate DNAC pushes, one for automation, one for telemetry, and so on. You really don't have to know all of them or remember all of them, but uh, SDN infra is very important because that's is completely for telemetry. All right, let's go back to device 360. This is the time series graph, so you can see when the event happened and all those things. Now what I'm going to show you is the topology view. So this is my switch, and it has detected one client because now we have enabled that wired telemetry, and this data is coming from that wired telemetry. That's how switch keep track of what is connected and what is not connected. These are a lot of system events coming from various telemetry sources. And now you see I have some default app experience, and this is coming from NetFlow plus N bar. So just checking the box on telemetry, you see, yeah, out of the box you are getting a lot of assurance benefit. Right now my device looks really healthy, not much going on. The health score looks good. Health score is composed of various parameter, not just if your device is reachable. So various things can impact uh, device score, and we will see how it's calculated and what you can do when the device score is affected. So now let's look at the final thing after discovery, that is go to tools and topology, go to the site where you have assigned the device. Right now you see this is some device, we are going to reset it so you can forget about it. So let's go to the device, and this is the device which we newly discovered and assign it to the site, and this is the topology looks like. If right now this is just one device, but you may have multiple devices here, so you can enable knobs what you want to see as a part of device topology. I want to see device health score plus the IP address and a host name. You can toggle them, and you can also uncheck check the view, and you can export this topology. So if you build a very long big topology, you can export it for your documentation purposes in various format like PNG and SVG. That means you can use it as a Visio stencil. So very useful, comes handy sometime for troubleshooting, most of the time for documentation and visualization. So this is this here we will stop this video. We have done the device discovery, assignment, and telemetry, which is a big chunk of uh, topology build. We have not started the fabric journey yet, but these are the prerequisite we should be doing, and it's very important to know because even if you want to build a fabric topology, you have to go through these steps for fabric devices also. So I know this was a long video, but I hope you were able to follow. And if you have any doubts and questions, feel free to come to our Discord room. I have a couple of other folks also, like, who have experience. Maybe we can help each other, right? Yeah. So please come to the Discord room, ask question. You can ask questions in comment section, but at least provide feedback how it is going so far. Are you getting any value, or are you saying any advantage with this SDA bootcamp, which is multi-part bootcamp? So please do tell me, and invite your friend to watch this bootcamp, and let's benefit each other. Thank you.